How's everyone?
Good, ma'am.
Good.
Good, ma'am. Good.
Okay. Okay. Today we are going to do a little mathematical stuff. Okay. So it will be little interesting, but it will be a little challenging. So let us see how it goes, right? But so we'll do a little bit of measures of central tendency, and then we'll go to probability distributions. So it will be a little fun, but I want to see in terms of how you can relate it to your current work. Okay, so that will be interesting to know uh, how you are going to use it in your current work. Okay, so let me just share my screen. Everybody can see my screen.
Yes, ma'am. It's visible.
Sorry. Okay, you can see my screen, right?
Yes, ma'am. Yes.
Okay, okay, great. Let me just reduce this and let me start. Okay. Okay, so this is what is called, it's called distributions. Okay, now let's say when you, let's say, you want to let's say count the number of people, and let's say you want to arrange them by age. Okay, so normally you will have some people who are like 12 years old, some 15 years old, some 18 years old, some 25 years old, right? And let's say you have these 100 people there. Okay, and if you arrange them by frequency, okay, you will possibly get a distribution. Okay, I'll clarify a little later, but let's look at this. Right now, in a distribution, three things are important. Number one, what is its shape? Okay. Number two, how do you find a single number that represents what it, what the distribution can, like an average out that you can look at? Okay, and how much is the dispersion, or how much is the spread of a distribution? Okay, so for example, let's say you want to look at an incidence of a disease. Okay, now the average percentage of hypertension is, let's say, percentage is, let's say, uh, 50% in an age group of, let's say 40 to 80 years old. Okay, but you want to find out that in terms of, like, what is the range, what is the minimum, what is the maximum, right? If you want to look at the range, then that is where spread is really related to. Okay, so now this is a data set of IQ scores. Okay, can you see this as a distribution? Okay, so you have IQ scores. Okay, and the bars that you see, okay, now these are called the frequencies. So for example, if I look at this, okay, if I look at 100 IQ score, right, approximately the frequency of this is around 80. Okay, so 80 people, when I sampled couple of people, right, so I found that among this there were 80 people who had 100 scores. Okay, if I look at something like, okay, let's say 70, then approximately only 20 people I found which had an IQ score of 70. So maximum value that I found was like 100, which is like 80, above 80 score, and then so on. So this is like a typical shape of what we do, right? So many of the things that we collect data. Okay, so for example, if you would, let's say you start maintaining a database of patients, okay, of those who kind of need palliative care, and let's say you want to measure them by their pain score. Okay, so every day patient comes, okay, and he says you measure him as per pain. Okay, and every day you kind of do this measurement. Okay, and let's say let's assume that you did this over 3 months, that's 90 days, and 90 days, let's say you got around 500 patients. Okay, then you can kind of convert this into this kind of a distribution depending on the pain scores that you have, because for a particular pain score you may have more than one person saying that pain score, right? So this is what you have in a in IQ scores. Now, a density curve is what is superimposed on this, right? You can see this curved line. Now, this is called a density score. Okay. Now, when you have this kind of distribution, like one is something like a, symmetrical, right? So this is a typical bell-shaped curve, which we normally call as a normal distribution. Okay, this is a continuous probability distribution, which is called a normal distribution. Okay, this is a symmetrical distribution, but it is not bell-shaped. Okay, so most of the statistical stuff in terms of hypothesis testing and stuff, we normally do with a normal distribution. Okay, which we won't do today, but I'm generally just taking you through it. Okay, and this is another symmetrical distribution, but you don't see a bell-shaped curve. Okay, now, there are some other shapes. Okay, so you may have a bimodal, you have a positive skew, you have a negative skew. So positive skew, what happens? Many of your observations will start leaning towards the right. So you will have more bunched out here, but the spread of your distributions towards the right side will be more. Whereas in a negative skew, you will have more smaller observations on the left hand side, and the bulk of your observations will be spread across a certain area. So this is called a negative skew. Okay, this is called a unimodal skew. Okay, this is a bimodal skew. So whenever you are sort of trying to kind of put in data, it's important to know the kind of distribution that you have. Okay, uh, sometimes you do not have a normal distribution, so sometimes you have to standardize a distribution, but we will not get into that right now. Okay, but the idea is that most of your statistical stuff, okay, your regression analysis and stuff normally happens when your distribution of your observations is symmetrical. Okay, it is a normal distribution. Some, like your logistic regression and stuff, you can still do with a not a normal distribution. You if your data doesn't follow a normal distribution, then you will probably need to revise the method of your statistical analysis. Okay, so that's just the thing that you need to understand. Now, kurtosis is something like, how peaked it is, right? So this is a mesokurtic medium distribution. This is like a flat, right? Which means you have like, okay, fat tails, okay, you have, right? And in this case, like most of you can see the distribution is very less out here. Here, the distribution is more, okay? So kurtosis is a measure of the degree to the which the distribution is peaked, okay? Now, you don't really be, unless you are doing a lot of statistical analysis, you are not really concerned. But yes, if you are visualizing your uh, observations, you should be knowing these terms. Okay, now what is an outlier? Okay, now you have something like a first quartile and a third quartile, okay, which we'll discuss a little later. So just to kind of you know okay. So have you ever found any data, okay, and you've collected a data and you found that somebody is, doesn't really fit the normal characteristics? Have you ever found or used any kind of that data? What do you normally say? What is an outlier?
Ma'am, which is outside the set range value.
Yeah, so normally we say that, this is an outlier, this is that it doesn't fit. Okay, now let's say, you were doing, let's say, a collection of income, people by income in a community. Okay, and most income was like between 10,000 and 15,000. Okay, and then suddenly you found somebody who had uh, an income of 50,000. Okay, now let's say you were averaging out these, you know 10 people, which are between, let's say, between 2,000 and 10,000. Okay, but if I add this 11th person with 50,000, what will happen to the average?
The average will be skewed to one side because of an outlier.
Yeah, it will not represent the population. Okay, because of the outlier. Okay, I have found that because of this 50,000 observation, and if I add it and I do an average, it doesn't quite fit my population, right? My results are going to be skewed. Okay, so therefore it is sometimes very important for me to find out, whether an observation is an outlier or not, right? Now their observation can be on the, higher side, it can be on the lower side. Okay, how many of you have ever used a box plot, seen a box plot? No. Okay, so at some time, maybe if I, okay, maybe my next class I'll show you what a box plot looks like. Okay, and a box plot is like when you kind of, plot your data, it will actually give you an indication of how many are outliers. So it will show you a visual representation that how much of your data is outlier. Okay, so if you know that x number of observations don't fit into your, normal, it is good to sometimes take it out and remove that from the analysis. Otherwise, your analysis is going to be skewed. Okay, so that is why it's very important to know whether your data set has any outliers. Okay, so you, as I said, you may be collecting a lot of data, but you need to know that if there is any particular observation which has very, values which is, way out from your, normal population, then it's best to remove that observation. Otherwise your results will become skewed. Okay,
Ma'am,
everybody
I have
good
a
with
doubt,
this?
ma'am.
Yeah.
Ma'am, this outliers, for what
Yeah.
kind of data should we see this, like only for continuous data variables, or for
So
what kind of interval data, or
So interval data normally will not be skewed. Okay, normally you have intervals. Okay, interval is categorically data. So normally you don't find skewness. Okay, but sometimes what happens is that even in those categories, if you find that there is a lot of, you have many categories, sometimes you may want to collapse categories.
Mhm. Okay.
Okay, so for example, let's say I start with, let's say start with income is okay, 0 to 1000, 1000 to 5000, 5000 to 10,000, 10,000 to, 25,000. Okay, and then I have more than 25,000. Okay, now I have an income level of somebody which is like 1 lakh.
Okay, that is outlier.
Okay, that is a pure outlier. Okay, so in that case possibly I may just want to collapse the category and I say, you know I would just say more than 20,000 and I kind of collapse those categories, so then it doesn't look like an outlier. Okay, either I leave that category totally, I remove that observation completely from my analysis, which is a far better way to do it. Okay, but sometimes if I don't have the luxury, then I collapse the categories if I'm using some categories.
And
Okay,
because of
because
this,
if you have just one or two observations on the outer end, then it doesn't work,
ma'am,
right? But then you have to make a judgment. It's your judgment at the end of the day. Yeah, my screen is not visible because I'm talking to you guys, right? At
ma'am,
times I close the screen because I want to speak to you.
ma'am, for this kind of thing, median is what we calculate, no, ma'am, instead
Yes,
of
for
average.
that kind of a thing, median is what you calculate, but a lot of stuff cannot be done with median.
Okay, so we
Okay,
need to
so that is
use
why sometimes we
outliers.
use something called a trimmed mean. Okay, and a trimmed mean, we remove 10% of the upper limit and 10% of the lower limit, or 5%, and then we work with that trimmed mean
Okay,
just to remove the outliers.
okay. Oh, now it
Okay.
is clear.
Okay, so this is what an outlier is, and this is the technical definition of an outlier. Okay, right, so it is um, greater than the value of, it is greater than 1.5 IQR. Okay, and when I say IQR, Q1 and Q3 are median values. This is the first, okay, let's just kind of do this first. Okay, okay, and n is the sample size. Okay, now if I have mean, okay, then this is like 21, let's say age is this, okay, then x1 is 21 and x2 is 42 and so on, okay, right? And my total of x is 290, okay, then the most common measure of my central tendency is the mean, that is 1 upon 10. I have 10 observations, I divided by 10 and I got 290, right? Now let us assume, okay, now let us assume this is not 52, this was 100, right? Then what would have happened? I would have added 290 plus 48. Agreed? If instead of 52, I had 100,
Yes, ma'am.
right? So it would have been 290 plus another 48. That would have been 338,
Yes, ma'am.
right? So in this case, then what would have my average been? What has happened to my average? It would have gone up by 3 points, around 4 points, right? Let's say. It would have been 338 divided by 10, that would be 33.8, right? So you know what an outlier, what an outlier has done? It's increased the size of the average. Got it, everybody?
Yes, ma'am.
Okay, this is the most common way of representing your data, is to find a sample mean of the data set that you have, right? So you normally say on an average the patients, that walked into my clinic had an anxiety level of, let's say, 50%, right? Or on an average, that the patients that walked into my clinic, on an average 20% were suffering from this, disease or this condition, right? Does this sound relatable now?
Yeah.
Okay, okay, let's not get into this. Okay, now what is the use of a sample mean? Okay, now right now what you have done is you have collected some data, you are doing a study, okay, and you have found that every, you've taken 100 people, okay, your thing, and you found that 10% of those who came to your clinic were suffering from diabetes, okay. Now obviously, this is a sample, okay, because you are doing this, okay, you really don't know that, whether or not that, 10% of the population is suffering from diabetes, but based on your sample you say that, okay, in, whether you can say that 10% of the population is suffering from diabetes, okay. Now that is the question, okay. Let me just stop sharing and let me just have a conversation with you guys, okay. Okay, so suppose you had a sample of 100 people and you found that 10% of these guys were suffering from diabetes. Now can you in general say that, in general, on an average, 10% of the population suffers from diabetes on the basis of your sample?
The samples are all from our clinic only.
Absolutely, right? So either you decided, and let's say, now let me change the entire scenario, okay? Let me assume that you took a specific area, okay, or a specific, let's say district or a specific block where you had 4 villages, okay, and 4 villages, and you, in a block in those 4 villages, you collected a representative sample from each village, okay. Let's say the village population was 1,000, okay, and let's say you looked at a sample of 25 to 75 age, and you know listed all the people in the villages from 25 to 75, okay. You found, okay, that there are, let's say, 500 people in each of these 4 villages, that they were between the age of 25 to 75, and you took a 10% sample of this 500 people, okay. and you found 50, 50, 50. So you got a 200 sample. Okay. Now from this 200 sample, now let's say you took a 10%, you found that 10% of this 200 was suffering from diabetes, right? Now can you say that in this block 10% of the population was suffering from diabetes?
This is
With
not representative of the population.
absolutely, now you can say with a greater degree of confidence that yes, 10% of the population in block X is suffering from diabetes. Okay, so now that 10%, that sample is representing the population of that block. Got it, everybody? Right? So it
Yes,
is
ma'am.
very important that when we do sampling, it has to, the sampling frame that we, is, if we construct it properly, then you can say with reasonable confidence that whatever the sample that I am saying represents the population at large, right? Whatever is the population of interest. Everybody okay with this? Right? Okay.
Vinti, 1 minute.
Yeah.
So you told if we take 200 takings or samples, and if
Yeah.
10% of them are having diabetes, then it will be representation of that block. But uh, uh, as I don't know anything, that's why I'm asking this question. Would that sample size will be enough? Because in a block there will be at least I don't know lakhs of people. So if you take 200 and say that 10% has diabetes, will it be correct?
Yeah. So Sunil, for that we have to do some sampling calculations. Okay. So normally we take population and then we look at the power of a sample. Okay. So right, and we look at the confidence level that we want. Okay, and then we take a sample. Okay, and we ensure that um, the sampling frame is correct. Okay, so obviously you obviously don't have lakhs and you take 10%, but you, if your sampling frame is correct, and let's say you take that confidence level, you can say with reasonable confidence, with 95 confidence percent, that we can say that this represents the incidence of diabetes in this block, right? And it may be a sample of only 500 people, but provided you have sampled properly. Right? Does that answer your question, Sunil?
Yeah, yeah.
Right? So that is something that we are going to do as we get along. Okay, it is something that we will study. Okay, but today we will do discrete probability distributions. Okay, where we are talking about binomial and Poisson. The other ones, in terms of the normal distribution and hypothesis testing, we will do in the next class. Okay, so today we are going to do binomial and Poisson, which are also distributions. Okay, but and are very are often used in the medical sciences. Okay, but let's just okay, so this is the mean. Okay, so here as I said, predicts value of an observation drawn at random from the sample. Okay, predicts value of an observation drawn at random, sorry, this is again, predicts the population mean mu. Okay, mu is represented by this symbol. Okay, so mu is the population. Okay, so your sample X that you have, okay, should be representative. The whole purpose is that your sample mean should fairly represent with some degree of confidence the population mean. Okay, that is what is the purpose of collecting the sample. Okay. Okay, now this is another one, is median. Okay, sometimes you don't have mean. Okay, but then you have, when you have too much of dispersion. Okay, then in that case mean does not work, so you basically you average the two middle values. Okay, it's not a very popular used thing, but if you want to look at a positional average, median is not a is not an average of the values. It is a positional average of how the values are placed in terms of position. So if you have an uneven number, you can always take out a middle figure. But if you have even numbers, then you will have to kind of average the two numbers, right? So if you have even numbers, so you calculate, suppose you have 10, okay, so then 10, you add 1, that's right, that's 5.5. So then what you do, you take the fifth number and then you take the sixth number, and then you take the average of the fifth and the sixth number, okay, and in this case the fifth number was 27, the sixth number was 28, and you calculated the average, and so you got 27.5. So that is how you calculated the median. Okay, everybody good with this? Everybody fine with this? No voices? Can you see my screen? Can you all see? Could you see my screen?
Yes, we can see the screen.
Now
Yeah,
we can.
Now can
Now
you
we
see?
can see. Yes, ma'am.
Okay, great. Okay, so you are here. You have right. I had this. These are the 10 values that I had. Okay, so my fifth number was 27. My sixth number was 28. So my median was in between the two. So I averaged out these 27 and 28, and that's my median value. Okay, so median is always called my positional average. Okay. Now, obviously, median is resistant to skews and outliers, okay, because it is a position, so it doesn't really matter, okay. Right now, here, suppose I have this, okay, instead of 1790, I have 9867. See, the median doesn't change, okay. So here in this case, my X bar, that is my average, is 1636. But if I have an error of, data entry error, and it was actually 9867, my median would remain the same, but my mean would have become 2743. Okay, so that's the reason why we say the median is resistant to skews and outliers. Okay. Okay. Now the mode is the most frequent value in the data set. Okay. So in this case, you have 3 times 7. Okay. So this is a mode. This has no mode. Okay. But a mode is only useful in large data sets with repeating values. Everybody good with this? Okay, because we are going to go very slow today because there's a lot of numbers. Okay, so as I've said, in a symmetrical distribution, okay, your mean is equal to your median is equal to your mode. Okay, so in this case it doesn't matter. Okay, but in this case, for example, in a negative skew, okay, your mode is likely to be more than your mean, and your median is going to be still where it is. But in a positive skew, okay, because you have more values out here, okay, you will have larger values more on the righter distribution, your mean is going to be more than your mode. Okay, in a negative skew, mean is less than your mode. Okay, in a positive skew, your mean is going to be more than your mode. Okay, everybody is clear with this?
Yes, ma'am.
Okay, great. Okay, so mean is more greater than median positive, mean is less than median negative skew. Okay, quartile is marks the bottom quarter of the data, middle of the lower half. Okay, so for example, if you have the same data set, okay, now this is also quartile. The first quartile is again the positional part of it. Okay, so I have 10. Okay, these are the 10. So this is the third is the quarter 1, quarter 3 is 42. Okay, and my interquartile range is 42 minus 21, that is 21. So this interquartile range is basically a measure of my distribution. Okay, and this basically covers the 50% of your distribution. Okay, so if you have Q1 and Q3, so you want to see that how much is the range which covers 50% of your distribution. Okay, everybody okay with this? Now these are just measures that whenever you do something, okay, whenever you look at your data set, okay, you want to understand how the data looks like. Okay, you want to see whether it is skewed, what are the cutoffs, what is the mean, what is the median, okay, what is the interquartile range. You want to see how spread out the data set is. You want to understand the data. So your measures of central tendency is basically your descriptive measures, and it gives you an idea how your data is placed. Okay, it helps you to understand the data. You need to sometimes, before you work on the data, you need to understand how your data is arranged. How does it, it starts speaking to you. Okay, so data also tells you a story. Okay, and before you start doing any statistical stuff, the first thing that you should do is understand your data. So typically, if I have to do an analysis, okay, and I have, let's say, 10 variables, I first do a frequency distribution of all my data, of all the variables. I will see the mean, I will see the interquartile range, I will see the frequency distribution. Okay, so that I get to understand, okay, what is the nature of my data, right? If I do, I need to sort of play around with it. Do I need to convert it into categories? In some cases, does it look like a normal distribution? Do I have to standardize it, right? So all of that needs to be kind of done, right? So as I said, if there is too many outliers, that I might want to remove the outliers and then do a average. Okay, so how many of you worked with, I'm just stopping my share. Okay, how many of you worked with standard deviation? Anybody's worked with standard deviation?
I have used but not understood it completely, but definitely all this BP variables and all these things were using standard deviations.
Okay,
Heart rate, BP variations.
why would you need a standard deviation?
So once the mean is found, to see how the other variables are either near or how much away from the mean, to calculate something like that.
So one way of doing this distribution, suppose you had to convert a, okay, I'll tell you a practical example. Okay, this is what I used to in my evaluation. I used to use a standard deviation. Okay, now at some point of time, you would have always evaluated somebody's marks, right? You would have taught in class. Okay, now let's say you have to teach in class and somebody is, there have been marks. Okay, so somebody has got 16, somebody's got 17, somebody's got 18, somebody's got 20, somebody's got 25, somebody's got 40, somebody's got 45, somebody got 50, 55, 60, 65, 70, 75, okay, 80, 82, 90, 95. Okay, now from 16 to, let's say, 95. Okay, now I have to assign grades to these guys. I've got marks. Okay, but I have to assign grades. Okay, and I know I have to assign grades in terms of, minus F, okay, minus D, minus C, okay, minus B, minus A. Okay, now these are the grades that I have to assign. Okay, now to assign these grades, I have to ensure that there is an equal number of people in all these grades, right? So what is my cutoff level for A? What is my cutoff level going to be for B or minus B? What is my cutoff level going to be for C? Okay, there my standard deviation helps, because it gives me an average dispersion of the data. So I can now say that, okay, on an average my dispersion is this. Okay, so therefore if I use this dispersion, okay, I can make these 6 different or 7 different categories and accordingly plot all the marks into these 7 or 8 categories. Okay, so that gives me a more reasonable thing, that okay, fine, it may not be perfect, but it gives me a sort of a way to plot these categories. Okay, now let's hear from you how you would use your standard deviation in your in your day-to-day life, okay, in your patient's data? Can you think of ways how you would use standard deviation? And we'll go around how to calculate it later, but anybody is in the idea in terms of how you would like to use standard deviation?
Standard deviation is the deviation from the mean only, no?
It's deviation from the mean, okay, and it has a very important role in standard deviation. Okay, I'll give you another example. Okay, I have two data sets. Okay, one goes from 50 to 150. Okay, and one goes from, let's say, 25 to 75, or to, yeah, 25 to 7 to 25 to 75, and the one goes from 50 to, yeah, 250, 100, yeah, 150, 160, but their mean is both the same.
Okay.
The mean for both these data sets is the same, right?
Okay.
Now, can these two data sets be compared? Because I have the same mean, you would probably say that, both these distributions look the same, but are they same?
The range is different.
The range is different. So typically we have a measure which is called coefficient of variation. Okay, we have a coefficient of variation, okay, that is the mean divided by the standard deviation. Okay, so that kind of converts into a ratio, so you can now compare one data set with the other. Okay, because the mean, it depends on the values. Okay, I may, as I said, I have 150, okay, some 50 to 150, I may still have an average of maybe 90, or maybe 75. Okay, and the other data set may also have a mean of 75. Okay, I don't know. Okay, or maybe in this case it will be 50. Okay, right, it may still, because it is 25 to 70, it may still have a mean of 50. The other one also has a mean of 25, 50 to it may still also have a mean of 50. Okay, but the variation is different. Okay, so there is where the standard deviation is important. Okay, in other ways also, right, let's say, okay, let me just first do the averaging and then we'll again discuss. Okay, now this is typically what an average looks like, what a standard deviation looks like. So what you do is, let's say I have, okay, let me see whether there's a calculation there. Okay, this is a calculation. Okay, so I have these 1 2 3 4 5 6 7 8 observations. Okay, now I have taken out first the average. Okay, so let's say the average out here was 36. Okay, so what I do is, from x to x bar, the average is, x bar is represented by average. Okay, the x bar represents that. So 36 minus 36, I will first find out the deviations. Mind you, when I find out the deviations from the average, the sum of the deviations will always be 0. Okay, because I'm taking out from the average, so the sum of deviations will be always 0. Okay, but if I square these deviations, then I will find the sum of squares. Okay, okay, and the sum of squares is this. Okay, sorry. Okay, so this is the sum, this is the sum of squares. X minus bar square is sum of the squares. But if I want to find out, okay, the variance, then I divide it by 1, n minus 1 divided by the sum of squares. And if I want to find out the standard deviation, then I take the square root of it. Okay, let's try a number. Let's do an Excel sheet. Okay, let me open an Excel sheet and let's try this.
In what all situation we have to calculate variance?
So normally variance for a, it is variance is the total dispersion. Okay, total dispersion. So normally we do it for financial stuff. Okay, I don't know in the medical field, but if I wanted to take out total risk, then yes, the variance is used as a measure of systematic and unsystematic risk. So that's the way I have used total variance. But normally for most calculations, statistical calculations, we usually used only standard deviation. Okay, so I'm just trying to do some numbers. Okay, let's say I have 45,
Ma'am,
50.
is this should we know the formulas of all these things, or if we know the concept that is in it?
Can you just speak louder?
Ma'am, should we know the formulas and derivations of this?
No,
or
you
if we
don't need to know the
concept?
formula, because all your statistical calculations, if you do use a statistical software or something of that sort, easily do it, right? So for example here, right, suppose I'm doing this.
So basically, we should know where we should use standard deviation and
Yes,
where
right.
we
So
should
for
not.
example here, if I want to do insert, okay, if I do a formula, okay, let me just see whether I can just formulas. Okay, so formula for this, okay, I have a statistical formula. Let's see, insert function. Okay, and let me just search for a function out here. Okay, statistical. Okay, and I want to do standard deviation.
Will the Excel is not visible.
Okay, so can you see my screen? No.
No, ma'am.
You can see the thing, but what you are doing is not seen.
Okay, one second. Let me just increase the screen. Can you see this now? Is it clear?
We are not seeing the Excel, ma'am.
Yeah, it's not the Excel, it's just a PowerPoint presentation that we are seeing.
You can see. Okay, let me just share it again. Yeah. Can you see the Excel sheet?
Yeah.
Okay. Now in an Excel sheet, right, there are many functions which are already there. One, I can do it, normally I can do it. Otherwise, insert function, okay, and let me use statistical stuff. Okay, statistical. I scroll down, so there is an average out here, right? So if I click on average, I will be able to find out the average. Let me just okay. Insert function. Okay. If I do average, okay, and I just select this, this is my average, this is my mean. If I want to do standard deviation, insert function, right, and there will be a standard definition out here, right? This is a standard definition of sample, stdv.s. I'll click on this, okay. I found a standard deviation. Okay, so Excel kind of does this, and any statistical application will also do it, right? So Excel has a host of statistical functions which you can use to calculate all of this. Everybody good with this?
I don't know how many of us knows Excel in detail.
Well, Excel is a very useful tool. Okay, so it's just like I mean, maybe sometime we can kind of do a small tutorial. Okay, but Excel is, I mean, at the end of the day, it's nothing. It is just like rows and columns enter data. Okay, so if I had to calculate a data sheet, okay, so this is my variable 1, this is my variable 2. Okay, I would enter data, and if I wanted to find out the average of this, I would just go here, and there is, if I go to insert, you go to this place, there's a formulas bar out here. You have file, home, insert, page layout, formulas, and here you have insert function out here. Okay, and here it will give you, in this case, of course, let me just go to insert function, and it gives you categories of functions, right? You have this categories of functions. example, you have financial, date and time, maths, trigonometry, statistical, lookup, reference, database, text, logical information. Right? So most of it we don't need, but if you do statistics, so these are the different statistical. So you can do a correlation, you can do a chi-square test, okay, you can do a linear this thing, you can do a frequency, right? So there is a lot of stuff that you can do. You can do a variance population, you can do a variance sample, lots of stuff that you can do which you don't need any other statistical tool for this. Some of it you can do in Excel. Okay, this is just to demonstrate that okay, you don't have to calculate it, you don't have to remember formulas. Everybody okay with this? Yes, everybody okay with this? I know it is the first time I'm introducing numbers and stuff, so everybody must not be liking me very much today.
Should we all learn Microsoft Excel now?
Well, Excel is good for keeping record of your expenses, of your patients, right? If you don't have an application or something and you want to do a little bit of that stuff, it's great for keeping basic information. Like we use Excel all the time.
Okay.
Right? We don't know what our life would be without Excel. In this case, nowadays we use Google Sheets. Okay, but very valuable.
Which is easy, ma'am? Google Sheets or Excel?
Google Sheets is basically a Google stuff. So most of the stuff that you do in Excel, you can do in Google, but except Google, it is easier to share data. You can just share the sheet. It's all online. I mean, for example, nowadays, I don't work in Excel in my office. We just do stuff in a Google Sheet, and I share the link. So it saves me the trouble of mailing it to multiple people. So we'll just click on the link, and that's it. Like you have those Google Slides and PowerPoint presentations, a similar Google Sheet. Right? So I can make graphs, pie diagrams, lots of stuff I can do with the Google stuff. Right? And it's, if you want to keep small records of your patients and stuff and make lists and stuff, it may be a good idea. And if you want to convert a data set, you want to keep variables, okay, you decide. Okay, I'm happy to help any of you if you want to start keeping some record of your expenses on some parameters. I'm happy to construct a simple data table for you, and then you can keep following up.
And this
Right, so
Google Forms creates it on its own. Some pie
Google
charts.
Form, you have to create a Google Form.
Okay.
Okay, the output will still come in a sheet.
Okay, so better to put in a sheet by ourselves.
See, depends. If you have many in a Google Form, you can either use a checkbox question or a radio button question, right? So if you have something which is like easier, you have many variables, then maybe a Google Form, create a Google Form and then do it. But if you have only 8-10 variables, then a Google Sheet will work.
See, for
But if
example,
you have many variables and you have many options,
ma'am, I'll tell an example. Like
okay,
for 30 patients, if I have to calculate only pain score or something which I can calculate.
then it's a Google Sheet works.
Okay.
Right. So for example, let's try this. Okay, I'm sharing my screen. Okay, let's say this. Okay, so let me just say, okay, and I have the name of the patient, I have the age, I have the gender, then I have the specific disease, right? And I look at the pain score. This is a simple thing, right? The patient name comes, calculate this, right? Disease or condition, whatever you want. Okay, and I want to look at the pain score. Okay, so I do this. So every time the patient comes, you just have to look at this. Okay, unite, and then you can accordingly, if you collect enough data, then you can make charts and graphs out of this also. Right. So for example, let's say I have, let's say A, B, C, D, E, F. Okay, and I have age 5. Let's say 35, 40, 42, 50, 55, 28. Okay, this is female, female, male, female, female, male. Okay, and let's say condition is A. Okay, X1, X1, and this is X2. Sorry, X2, X2. This is X3. This is X3. Sorry, 3. Okay, and let's say I have 45, 25, 30, 56, 75, 28. Okay, and let's say I want to construct this. Okay, so what I will do is insert, right? I will go to recommended charts. Okay, I want to do a bar diagram, say bar diagram, or I want to say column bar here, right? So I will have this, right? Of course, in this case, I have not categorized it well, but I will have this pain scores, right? I haven't done a frequency distribution, that is why it is doing this. Okay, I may have to adjust my data, but it will give me this bar diagram. Right, and there are many options that I can do. Okay, so I'm going to stop share and I'm going to go back to my slide presentation. So this is my distribution. This is okay. Now this is another example. Okay. Okay. So this is an example, is that we were looking at the craniofacial morphology of patients diagnosed with obstructive sleep apnea in healthy male subjects. One of the demographic variables that the collectors was the body mass index by dividing the weight in kg by the square. Okay, so we were looking at only the BMI index of these patients. Okay, so all these patients who were diagnosed with craniofacial morphology, so we looked at the BMIs of that. Okay, now in this case, okay, so there was a huge number of variants. So what I divided it was on class intervals. So my lowest BMI was 20 and my highest BMI was around 55, okay, or maybe 52 or 53. Okay, so this was my BMI. Now what I have done is I have divided this entire distribution into class intervals. Okay, so it was a continuous variable. BMI is a continuous variable. So I made the class intervals of 20 to 24.99, 25 to 29, and then I said that in this interval, how many patients BMI score was between this interval. Okay, so I took out a frequency of this. My cumulative frequency, if you can see, the first will be 2, then it will be 2 plus 11 is equal to 13, 13 plus 6 is equal to 19, 19 plus 2 is equal to 21, 21 plus 5 is equal to 26, 26 plus 2 is 28, and 28 plus 1 is 29. So the last value of my cumulative frequency is going to be the total of my frequency. So in this case, I had 29 people whose subjects that BMI that I studied, and this was how they were divided. Okay, now this is what is called a histogram. Okay, so in a histogram, I have these equal class intervals. Okay, and as you can see that the height of the bar represents the frequency. Okay, the height of the bar represents a frequency, right? So you have the highest frequency of 11 in 25 to 29.1. So this is a way to visualize your data. Okay, so by looking at this data, you can find out that, okay, most of my subjects were between this. Okay, and the rest, okay, example 30 to 30 were only 6 people, and 50 to 54.99, okay, there was just one person. Okay, if I just looked at the frequency like this, then this is called a frequency polygon. Can you see this? I don't draw these is a histogram, but if I just plot it against the frequencies and the class interval, So 20 to 24.9, the midpoint is what? 22.5. Okay. So if I plot this, okay, this will kind of represent the frequency interval. Okay. This, on the other hand, okay, this is a cumulative frequency. Okay. So this, the cumulative frequency, if I look at the 6.9, 44.8, okay, 65.5 to 72. So this is my frequency. So you can see how the curve is going up. Okay. This is a cumulative frequency, which is also called an ogive. This is the result of a statistical, I use this data in a statistical, package. So it gives me the percentiles. Okay. So number one, it gives me a sort of a detailed value that, okay, these were the 29 observations. Okay. The mean was 33.87. The standard deviation was 7.99. The variance was 63.96. The skewness was this, and kurtosis was this. So it kind of gives me how my distribution looks like. Okay. I think there are a lot of chat figures. Okay. It's like Greek and Latin. Okay, okay. I'll come to the square business later on. Okay. Okay, everybody is good with this? Does this look interesting now? What I have done is I have taken your data, single variable, and I have mapped it out. Now I understand what the BMI looks like. I have done something with this data. Okay, Biju has not understood anything. Great. Okay, no problem.
Ma'am, actually, we want to know for what kind of variables we can use such things.
Okay.
Like BMI is an
okay. I'll say okay.
Us.
How many of you read? All of you read newspapers, right?
Yeah.
All of you follow election campaigns.
Yeah.
Right? Everybody follows. Everybody votes.
Yeah.
Okay. I'm sure everybody votes, right? Dr. Jagati is, pressing her head. She says, "What is happening?" No, don't worry. We'll all arrive somewhere. No issues. Don't worry. Okay. So everybody votes. Everybody. So you see the election analysis on television after the elections are done. How many of you watches?
Yeah. They put a lot of graphs, lot of bar
Right.
charts.
Those guys are doing exactly what we are doing.
Okay.
Just a little bit more sophisticatedly, but exactly what we are doing. So for example, they're saying that, okay, in rural areas, the percentage of votes polled by Congress was last time was this. Okay. And the average percentage of votes polled by BJP was this. In the last elections. Now in this, let's take the Karnataka elections. Let's say this was, let's take that as a case study. Okay. So in Karnataka, okay, the last time the rural constituencies, okay, 30% of the vote of the rural vote went to Congress, okay, and 40% of the vote went to BJP. Now what is that 30% and 40%? It's an average.
Okay.
Okay, what is it? They're doing an average, right?
Okay.
Right. Now they may also do this average as per community.
Okay.
Right. Now, for example, now let's go on to this. Okay. Now all of you, they kind of predict the test results that before who is going to win.
Yeah.
Right. Now, how do they do that? They do a sample. They don't actually go to every voter, right?
Yeah, there is sampling.
They don't go to every voter. They actually run, and then they go to every voter and they interview some voters, and then they ask them, who they're likely to vote.
Ma'am, I have a suggestion, ma'am.
Yeah.
Ma'am, instead of taking these theory topics from statistical point, um, like how we discuss in other classes, we have a case scenario. From there, we go to palliative concepts. Same way, we can take a research paper in palliative journal, and you can tell us how the statistics was approached in that particular research.
I can definitely do that. But does
Then
the
we can
papers in the
relate more why
yeah.
this has to be used in such a scenario. Like, so when we see like more than 10-15 research papers like that, then we will understand what kind of statistics should we do, what skills should we develop, like that.
So the problem is that all these research papers are very dense right now.
Huh?
Are very dense. I can show you these 5-6 papers, but they are very dense.
No, ma'am,
Okay.
we will come
Right
up
now
with
we are going at a very
some
basic
papers.
level. Very basic level where I am just explaining you the measures of central tendency. I am
Okay.
doing nothing more than that right now.
Okay.
I have not gone into any statistical analysis at all right now.
Okay.
I am only explaining to you if you are collecting data. Okay. What does your data distribution look like?
Okay.
Okay. There is nothing more that I am doing. I am only looking at your data distribution.
Okay. These are very basic stuff then.
This is very elementary stuff.
Okay.
Right. So for example, if I had data on the pain score across 100 patients, and if I just, sort of kind of distributed it, okay, these are the basic statistics that I would do.
Mm.
Okay, so for example, in this case, okay, let me just open a package. Okay, let me just see if I can find out that file. One sec. One sec. Just let me open a file. Okay. Okay. Yeah. Okay. Okay. This is a statistical package which is called Stata. Okay. So what I'm going to do, this is called BMI. Okay. This is a BMI. Okay. What I'm going to do is, okay, this is this editor. Okay. I'm going to convert this. Okay. I'm going to say rename. Okay. So what has happened is now I have converted this into pain score. Okay. Now this is what my data looks like. This is what I have. Okay. Assuming this is a pain score. Okay. Everybody okay with this?
Yeah.
Yeah.
Pain score will
Okay.
be less than 10 only, ma'am.
Never
0 to
mind.
10.
I'm just saying, let's assume this as a pain score.
Okay.
No, let
Just
it be
assume. For the sake of assuming, let us assume this is pain score.
Okay.
Okay. Now, I have this, this file. Okay. I am going to just, don't worry about the command. Just see the output. Okay. Okay. Now what I have done out here, I have tabulated it. Okay. So there were 29 observations. Okay. And here you can see that each pain score corresponds to only one frequency. Can you see this? Okay. The next thing that I'm going to do, okay, is let's say I am going to do a histogram of this. Okay. Now what can you see out here? Can you see this histogram?
Yes, yes.
Right. Now this is how my distribution of my pain score is.
Okay.
Between this range to this range, okay,
Okay.
so many people, okay, the height of the bar is the frequency. So this is the number of people which had a pain score of between this level and this level, right? So here I have constructed 10 bins. These are 10 categories. Okay. Okay. Now I can also do something like a the statistical package allows me to do this, but I'm just, for example, just kind of telling you this. Okay, sorry.
So this is all about data distribution.
Yeah, this is all about this data distribution. Okay, let me say pain score. You have to first understand your data. There is no rocket science on this. If you don't understand your data, okay,
Okay.
uh, it's very difficult to work with data.
Ma'am, even before data collection, should we know some of these things to start data collection?
It's a good idea to understand this thing, but I mean data collection, right? So here what I have done, okay, is I have constructed bar charts of all these variables. Okay, so this is the blue is the mean. Okay, this is the minimum of the pain score. This one, okay, this green bar is the minimum. This is the right. This is the maximum pain score that you had. This is the percentile, 50th percentile or the median. Okay, and this is the interquartile range. That is the Q3 minus Q1. So this gives you a kind of a, you know, a graphical interpretation of what your data looks like. Okay, let me just do another one. Okay, let me just do. Can you see this? Okay, so here what you found, 29 observations. Your mean was this. Your standard deviation was this. You get an understanding of what your data is. Okay, this is the first step to understand the nature of your data. There is nothing, you know, there is no great analysis that you're doing except trying to find out your measures of central tendency. Okay, you're not, right now you're not doing any statistical analysis. It's in the next stage that we start, you know, when I get the mean, I get the standard deviation, I understand what the distribution is like. Only then I decide, okay, this is the kind of statistical method that I will do. But first I need to understand the data. Okay, so this is the first step in disciplining yourself to understand what things look like. Right? It's like okay, just on a very laughing note. Let's say you get 100 CVs of, okay, those who are fathers, okay, and who are fathers of daughters. Okay, let's say you are looking for a groom for your son. Okay, and you put an advertisement and you get 100 CVs. Okay, now you may have age, you may have qualification, okay, you may have, you know, maybe caste, okay, maybe you have something like occupation, maybe you have father's occupation, maybe you have income level. Okay, and then you would want to do an average of all these variables and try to see that, okay, how many were, graduates, how many were postgraduates, within postgraduates, how many were doctors, and if they were doctors, how many of them were like, orthopedic surgeons, right? I'm just saying, what is the average age that they were, right? Won't you like to do this analysis? Right, suppose you were looking at different districts, okay, and you were looking at patients. So how many patients were having, needing uh, you know um, you know palliative care at home, how many would need palliative care at, at a facility, how many would, what is the average number of people, right? So this is just that averaging out, right? And you have this huge data set and you want to represent that data set in a manner which makes sense to you. Okay, so those are called measures of central tendency. Okay, so you need to understand what are the measures. So mean, median, mode, right? This is all measures of central tendency that we have done. Okay, now let's go on to the next. Okay, sorry, this is not what I wanted to do. Sorry. Okay, this is what, okay. Everybody can see my screen?
Yes.
Okay. Okay. Now let's look at probability. How many of you have done probability? Everybody understands what probability is? How do you say it is going to rain today? Okay, let's say a patient comes to you, right? Now, and how do you say this probability? And you see some blood test and you say, okay, what is the probability that this patient is going to develop liver disease? How do you do that?
That p-value you're talking about, ma'am?
Okay, let's understand probability. How do you say, okay, the probability that people will have asthma is 20%. How does this probability come?
It is from data analysis.
I mean, all of you are throwing statistics, right? Right. That is p-value is different, right? Let's not get into the p-value right now. Okay. We will discuss p-value later. Okay. I want to understand from you what is just probability. Right? How do you come to this conclusion that anybody who has got, let's say, a creatinine level of, let's say, 5 is going to die within 6 months?
That is by looking at previous.
Absolutely. You've got it, Dr. Sunil. Right? So obviously somebody would have done a sampling, okay, and say that for every 100 people that get, you've sampled, 20% of people would have had asthma. So you say the probability of something, because you have, based on your previous, this is called classical people, okay, classical probability, that okay, in 100 cases 20 people had asthma. So you say the probability of people, having asthma is 20% in Delhi. It may be only 10% in Kerala because the air is much better. Right? We deal with all of this all the time. Okay, let's type in the chat box. Okay, what kind of probability? How many times have we used probability. We'll figure it out later. Okay, let's have a, the thing is that whenever you use probability ever in case of a medical statistic, can all of you just type in the chat box? Whenever you have used a medical statistics based on probability, and in used in your normal conversation, the probability that this guy is going to not survive is beyond 6 months. Okay, probability of developing lung cancer smokers, great, very good. Let's open the chat box. Predictor of survival, odds ratio. Okay. Odds ratio is used in logistic regression. Anybody else? So everybody is rolled a dice. You know a dice, it is 6. It has 1, 2, 3, 4, 5, 6. Okay, so if you roll a dice once, what is the probability of getting 1?
1 out of 6.
Right? That is typical classical probability, that you basically look at, the incidence of that happening compared to the total outcomes that you have. Agreed on this? Right? In a classical probability, if you repeat an experiment, if you roll a dice, okay, it's typically that, okay, if the positive outcome or whatever the outcome that is desired divided by the total possible outcomes that you can get, you divide it by that and you will get your probability. Okay, that is what is called a classical probability. Okay, now,
But
and a
single
relative,
variable.
yeah,
This is a single variable, no? Ma'am? Like if you have
it's a single
multiple,
variable. Okay,
it is going to be
now
more.
let's say, right, you've done a sample. Okay, you sampled, okay, people, and you got some incidence of, let's say, breast cancer. Okay, then again you sampled, again you get a breast cancer. Okay, and you repeated this sample many times. Okay, right, over a period of time you've done this again and again and again. Okay, right, now the average amount that you are going to get, the average number of positive outcomes, right, will resemble the the classical probability, right, because you have, in this case there were only 6. You knew that in a dice you hold there were only 6 possible outcomes. Okay, but if you are repeating the experiment multiple times, okay, so that incidence becomes the probability, right? So suppose you have this breast cancer and you do a sample and you find that 10% of the sample find, and you repeat this and every time you find 10%, you said, okay, right, if I sample people, if I sample women, 10% of them are likely to suffer from breast cancer. Okay, I'm just making this up. Okay, so this is what is called a relative probability. Okay, yes, example, probability of a patient dying in 6 months in patients with primary metastatic cancer, right? So everybody of you understands probability. There is not a single person in this room who does not understand probability, except that we may not have done the computation. Okay, that's the only thing that we have not done. All of us understand it, but we understand it without doing the calculation. Today we will end up doing the calculation. Okay, so we'll at least start with the calculation. Okay, I try and not make it complicated. See, I am duty bound to show you the formulas. Okay, but as long as you understand the concept of how it is calculated, it is fine. Nobody is asking you to calculate it. Right, we are not asking you to calculate, right, and never any situation of you asking to be calculated. All we are saying is that you understand it. There is no requirement of any of you to calculate anything, right? The objective of this course is never to make you do any is to do any calculation. The objective of this course is only to make you understand the concept. Okay, so that you are at par with maybe some of your, let's say, counterparts in other countries. So if somebody is talking about this, you know exactly, okay, this guy is talking this. Okay, I know what he is talking about. Okay, and many of us don't know anything about anybody. We keep on throwing jargon, but as long as we can do intelligent jargon, that's great. Okay, right? So please don't get nervous. Not to get nervous at all. Okay, okay, let me just share my screen. Okay. Okay, so these are probability distributions. So let's read it out. Okay, in an event can occur in n mutually exclusive and equally likely ways, and in m of these produce a trait E, the probability of the occurrence of E is equal to m. So this is a classical definition. So in this case, let's say in a dice, right, there are 6 outcomes. The total amount of outcomes is n, and m is, the if I want a specific outcome m, that is 1. Okay, then that is 1 by 6. Okay, this is m by n. Okay, now on the other hand, okay, if a process is repeated number of times, okay, now here in this case I don't know, I'm doing this sampling multiple times. Okay, and if, let's say, this breast cancer occurs m times out of those n number of, okay, so if I say that if I do this sampling n times, and I in each time in the sample I find that, okay, 5 out of those, things, in I found those 5 instances, then my frequency, that my probability is m by n. Okay, very simple. Okay, prior probability is based on my prior knowledge, and posterior probability is something that I have calculated based on my data. Okay, so I know something from previous, that is prior, and posterior is something that, okay, I may have, done some new studies, and I may have revised my probability. That's it, nothing else. Beyond this we don't need to do. Okay, now I have this slide. I want to know whether you guys have ever needed to do something like a sensitivity or specificity of a test at any point.
Ma'am, there are many rating scales and scoring systems in palliative. So we can check the sensitivity and specificity of those scales.
Sensitivity and specificity. Okay, so I am going to share that calculation. Okay, right? As I said, you don't have to calculate. There are packages which you'll probably be able to do it, but if you understand it, you can do your own calculations. Okay,
because a lot of prognostication scoring systems are all there.
So that is why I included it, because in biostatistics this is required. Okay, if it was not required, I would have not done it. Okay, now for example, let's say I have a disease. Okay, now I do a test result of that disease. Okay, and and in that person the disease is actually present. Okay, so the person has a disease, and the test also indicates that the person has a disease. That is A. But there may be times when the person has the disease, but the test does not detect it. Right? That is always possible. Right? The test does not show up.
Yeah, possible.
Right? Possible. Now that is C. Okay. Now in this case, in the second case, the disease is absent. Okay. The person does not have the disease, but the person, we conduct a test and we find for some reason that we say that no, the test is positive. Right? We say no, this person has a disease, but actually that person does not have the disease. Right? And then there may be a situation is the person does not have the disease, and the test also shows it is negative. Okay. Now, these are the only 4 scenarios that you will have. Okay. These are the only 4 scenarios that you have. Either you have the disease or you don't have the disease. Either the test result shows that the disease is present, or the test result shows that the disease is not present. Okay. So this matrix of A, B, C, D has been constructed. Okay. So if you have a positive result, okay, then the total number of observation is A plus B. If you have a negative, then it is C plus D, right? So the T bar that you see is negative. Okay. If the disease is present, it is A plus C, and if disease is absent, then it is B plus D, right? And these are the number of instances or individuals that you may have, right? So you did a test, okay, you had 100 people in your sample, okay, and maybe later on the test was you found that the disease was there, and you also constructed a test, okay. So sometimes the person has a disease, it has a disease, but the test result doesn't show it up, right? So you've constructed this matrix, okay. So the sensitivity is, what is it? That the disease is present, and if the test result is positive, okay, so it is A divided by A plus C. That is how good your test result is, okay. That whether or not, if you interpret it that the person had the disease and the test result showed it up also, so A divided by A plus C, right? So the higher the A is with the total of A plus C, okay, if the C is less, then my sensitivity is going to be more, okay. If you are talking about specificity, then in terms of D, right, you are saying negative, the disease is absent, and the person is also showing negative test results. That is D divided by B plus D. Okay. Now let's just do it you want to do it in an Excel sheet?
Yes, yes, please do.
Okay, let's try and do it in an Excel sheet. Okay, now let us open an Excel sheet. Okay, let me open a sheet. Okay, now let's construct a scenario.
In the Excel is not visible.
Test positive.
Excel is not visible.
Okay.
Your Excel sheet is not seen.
Okay, let me just show this one second. Okay, one second. I think, every time you again, screen, leave it, then, okay. Okay. Now this person has the disease, does not have the disease. The test is positive, test is negative. Okay. Now, give me a figure out here. Test is positive. Let's say I have 75. Okay, I have 100 cases, and this is 25. Test is positive, okay, but does not have the disease. Okay, let's say this is 12. Okay, test is negative and does not have the disease. Let's say this is 78. Okay, is this okay? Everybody good with this?
Yes, ma'am.
Okay. So what is my sensitivity?
Indeed,
Yeah.
in the column D, should it when we add the 2, should it be 100? It's only 98 plus 12.
Okay, this is 78. This is 22. This must be total. That means these are 200 people, right?
Yes, ma'am.
Okay. So let me just say that this is auto sum. Okay. Okay. These were the people. Okay. So what is going to be my Sensitivity
75 divided
75 equal to 75 divided by 100.
100.
Right? What is going to be my specificity?
78 divided by 100.
78 divided by 100. Everybody good by this?
Yes, ma'am.
Okay. Now let us go to a example. Okay. Okay. Okay, let's not discuss anything else. Okay. A medical research team wished to evaluate a proposed screening test for Alzheimer's disease. The test was given to a random sample of 450 patients with Alzheimer's disease and an independent sample of 500 patients without symptoms of the disease. Okay.
We can
So
see the
random sample,
PPT.
we knew that 450 have the disease, and an independent sample of 500 patients which do not have any symptoms of the disease. The two samples were drawn from populations of subjects who were 65 years of age or older. Okay. Now what we found, and we conducted a test. Okay. So we found that 436 of them who had a diagnosis of Alzheimer's, and the test results were 436, and those who were negative was 14. Okay. Among
we
the
cannot-
Alzheimer's, yeah.
Ma'am, we cannot see the PPT. Are you reading?
So one sec. Let me stop share again. Can you see that now?
Yes, ma'am.
Okay. So here is that we had an Alzheimer's disease for a random sample of 450 patients. So random sample, those we had a diagnosis 450. Those that did not have a diagnosis was 500. Okay. And then we gave them some tests. Okay. And those who showed positive for Alzheimer's among the 500 was 450 was 436. And those who showed a negative result of 14 test was 14. But we had made the Alzheimer's diagnosis in terms of their otherwise, maybe in terms of the way they were behaving, but maybe there was some other test, which we conducted. Okay. Now this is what we find. And those we did not have an Alzheimer's diagnosis, but we constructed we did a test. So they were positive 5, okay, and negative 495, right? So we knew that these 500 people did not have a diagnosis, but the test results for some reason showed 5, okay. Now we want to know what is our sensitivity going to be? 436 divided by 450.
Yeah.
Okay. And what is my specificity going to be? 495
divided by 500.
500. Absolutely okay.
Yes, ma'am.
Okay. Shall I stop here, or are you comfortable going a little forward another 10 minutes more? Is this enough for today?
I think so, because
Ma'am,
there is
this,
no response.
sensitivity and specificity.
What is the probability of people who want to end the class today? Right now.
What, ma'am?
What is the probability of people who do not wish to, study further today? Right. So let's find. Right. So now today, for example, now he says Dr. Biju has calculated sensitivity and specificity. Now he knows exactly what it means. Isn't it a great feeling?
Yeah. Ma'am, this sensitivity and specificity can be calculated for some test which gives results only like either positive or negative, not for these gradings and all.
You'll have to give me a case example and we look at the data and then we can see. Next time, if you can just mail me the data and we'll see.
Okay,
Okay.
sure. Yeah.
Okay. So let's just look at that.
Yeah.
Okay. But as I said, basically, if you were able to understand the concept, it's great.
Yeah.
Okay. So for example, Dr. Biju has rated, for example, the sensitivity of antigen test for COVID is 50%, but the specificity is 90%. Okay. Negative. Okay. So that is okay. But RT-PCR for COVID specificity is 90% and the sensitivity is also 90%. It makes sense. It shows that the RT-PCR is a much better test.
Yeah.
Right. So if the antigen for COVID is positive, okay, then there is no need to do RT-PCR as the specificity is also high.
Yeah.
Right.
Yeah. Yeah. Got
Okay. So if somebody has been detected as I don't have it, then
Yeah.
there is no need to.
Madam, we did this because in the height of COVID, when the RT-PCR was not available that frequently, and it was very costly. So we used to
Okay.
do antigen first. So if the
Okay.
antigen came as positive, we understood that it is COVID because the sensitivity is high. No, sorry, sensitivity is low. Though the sensitivity is low, the specificity is high. So if the specificity is high in antigen, then we know it is COVID without doing the RT-PCR. So we used to
Okay.
save time and money with that.
Okay. Okay. Great. Okay. Fine. That's good. So everybody is saying stop class for today. Excel sheet, madam. You need an Excel sheet for this?
Madam, in the next 10 minutes, what are you going to talk about? Let us
Anything
know
that
that.
you want to talk about. We can talk about movies also. Right? We can talk about what you are going to do on a Sunday. Right? We can talk about, what do doctors
okay, but
what do doctors do on their weekends.
Madam, but is it okay if you can, as Dr. Punita was saying, to teach us something about Excel? I mean, we are all Greek to us on about Excel.
For that, Dr. Sunil will, we have to end this relationship with Statistics Without Borders, right? I can come only without Statistics Without Borders for that. I'm happy to teach you guys. Is not a problem. But right now we'll have to stick to the course.
Yeah, okay.
Okay,
So
so
we
let's finish the course.
Okay.
Right, my objective, as I said, it's not important that you do the calculation. My important job is to you understand it, the concept. Right, so today it was a difficult task because for the first time we were dealing with numbers, but we have a long way to go. Right, so I thought I will do binomial distribution and Poisson distribution. Okay, but I think we'll have to defer it.
Next class.
Okay, Shri Priya, what is it? Paul from Shri Priya, what is it?
They wanted me to launch one poll so that we can see who all are against stopping the class and who all are in favor.
No, I think we have this, we have these, we have these reactions, no?
Yes.
Right? So, you can always do these reactions. Okay, how many of you want the class to continue? Please put a smiling face. Not a single smiling face. Okay, great. So today we learned probability. Great. Fine. Okay, so I think Shripriya will end the class today.
Okay. So thank you, Vinti. It's like we are maybe probably in LKG, and you are our teacher. So it will be like that. So
As long as you guys are enjoying, it's okay.
I think everybody will get something.
Everybody will
get something out of this one.
Okay.
At least they will understand these are the things that is going to come in statistics or in terms of things. So they will be familiar, and even they might go one more step and see whether we can calculate. So without the specificity and sensitivity. So maybe somebody might be looking at that. Like Dr. Biju, who was telling, I don't know anything. At last, he came up with COVID antigen test, and he was teaching us regarding sensitivity and all.
Okay. No, it's actually, teaching for me is actually, I actually enjoy teaching. Okay. So for me, it's a labor of love. Okay. It is totally a labor of love. And I feel very happy if any of you get something out of it at the end of the day. For me, it is a great source of personal satisfaction.
Okay.
Okay, good
Uh,
night. We'll meet. We'll
so
probably
now
meet next Saturday. Okay, bye.
I believe everyone will
next
be
time
looking forward to that.
Yeah, next time we'll do Poisson distribution and binomial distribution. Right? And we'll start with, also the normal distribution also. Okay? Okay. Yeah.
Thank you so much.
Okay.
So thank you, Dr. Vinti, so much. And I believe that you too would have had a very busy week and a busy day as well. So thank you so much for being so patient with us. And thank you so much for considering our genuine comments and feedbacks. Yes, of course, your feedbacks will reach you on Monday. We are in the process of collecting that. It will definitely reach your mailbox on Monday.
Okay.
Thank you,
But I
everyone.
must tell you, Shri Priya, what did I do today? Okay.
Sure.
In the afternoon from 11 to 1:30, we had this organization which is called Rural Women's Development Trust. Okay, so in my organization, we have done an intervention with them, and we had to conduct a training on how to collect data using a data app. They didn't understand Hindi, they didn't understand English, and I don't speak Tamil. And none of my team also speaks Tamil. So
So,
we got hold of one program person. Her name is Nora. So before the training, we got hold of her. I said, you spend time with us for half an hour. So we took her through the entire questionnaire, and then we did the training. She translated in Tamil, right? And it was hilarious, but we managed.
ma'am, you could have easily told us. I think we have a couple of Tamilians in our group. Dr. Punita herself is a Tamilian. I am a Tamilian.
Okay.
Dr.
So
Vidya Saran.
next time I can get caught in a jam, I'm going to I'm going to resort to this group that I need help in translations.
Sure, ma'am. We did love to. Right, Dr.
Okay.
Punita?
Okay. Good night, everybody.
Good night, ma'am. Take care. See you in the next session. Bye-bye. Thank you, everyone, for joining. This is Sri Priya along with Dr. Vinti Agarwal and Dr. Sunil Kumar signing off from the Parameters. See you in the next session. Till then, everyone, take care. Keep learning. Bye-bye.